In this video, we're going to be talking about even and odd functions. So by definition, an even function f of x has the property that f of negative x is equal to f of x. So on the graph, this means that it will be symmetric around the y-axis. So for example, this function here. If we're looking at an integral, let's say from minus a to a, what we can see is that we could split the area from minus a to 0 and then from 0 to a, and it would be simply twice the area from 0 to a. So in other words, the integral from minus a to a of an even function will equal twice the integral from 0 to a of that function. Now, if we have an odd function, then f of negative x is negative f of x. So the graph of an odd function might look something like this. And in this case, if we're looking at integrating between minus a and a, what we'll see is that the areas cancel out, meaning that the integral from minus a to a of an odd function is just 0. For this example, let's look at a very complicated integral, the integral from minus pi over 2 to pi over 2 of 10x to the 12th times the sine of 7x over 1 plus x to the 10th. There's no way that we can analytically solve this integral. However, let's see if we can check and see if this happens to be an odd function. So what we want to do is we have f of x is 10 times x to the 12th sine of 7x over 1 plus x to the 10th. And we want to see what f of minus x is. So everywhere we have an x, we replace it with minus x. So we'll have 10 times minus x to the 12th times the sine of minus 7x all over 1 plus minus x to the 10th power. And now this will be 10 times x to the 12th times, well, the sine of minus 7x is minus sine of 7x, so this will be times minus sine of 7x over 1 plus x to the 10th. What we notice is that f of minus x is minus f of x. So we notice that f of minus x is minus f of x. So what this means is that f of x is an odd function. So we have an odd function evaluated between a negative and positive value. So this integral will be identically 0.